Hello everyone, we are materials engineering students and today we are excited to present our laboratory project titled Mastering the Mold. Our primary objective for this project is to successfully produce a high quality wetware ceramic product by utilizing the precision of the slip casting method. The specific product we have designed is a ceramic bowl, a choice that requires us to maintain a exceptionally smooth surface finish, achieve a uniform wall thickness throughout the body, and ensure the final piece is free of minimal defect like pinhole or warping. To achieve the rigorous standard, we selected slip casting as our primary fabrication route because it is uniquely suitable for producing complex, non-symmetrical shape and intricate hollow structure that would be difficult to form otherwise. When compared to alternative industrial methods such as dry pressing or extrusion, slip casting is superior for our goal as it provides significantly better surface quality, finer detail reproduction, and tighter dimensional control over the final geometry.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ku Muhammad Arif bin Ku Muhammad Azril. My metric number is 24210075. In this project, we use a triaxial blend consisting of kaolin, bole and feldspar. Kaolin provide plasticity and allow the material to be shaped easily. Bole improve strength and reduce shrinkage during drying and firing. Feldspar act as a flux which lowers the melting temperature during firing. The raw material will first measure and then mix the water to form a slurry known as slip. The water to solid ratio must be controlled carefully. Too much water weakens the structure, while too little the slip difficult to pour. Defloculant can also be added to reduce viscosity and improve the flow of the slip. Usually we use three type of raw material like kaolin, bole and feldspar. And then after we combine the material together, make a slurry. Then we put into the mold made by POP to the like a birthday shape.
The liquid slip is carefully poured into a plaster of Paris mold. This mold is specifically chosen because plaster of Paris is highly absorbent. As the slip sits inside the mold, the plaster starts to pull water out from the slip. When this happens, a solid layer known as the cast wall begins to form along the inner surface of the mold. This layer slowly thickens over time, and the longer we leave the slip inside, the thicker the wall becomes. After a certain period, usually depending on the required thickness, the excess slip is poured out. By removing the remaining liquid, we end up with a hollow shape inside the mold. This is how many ceramic objects like cups, vases and figurines get their form. Next comes the drying stage, which is a very important part of the process. Once the excess slip has been drained, the product is left to dry inside the mold. This allows the piece to harden enough to be handled, but at this point, it is still not fully strong. When the piece becomes firm enough, it is carefully removed from the mold. When the piece at this stage, it is known as greenware. Greenware is extremely fragile, so we must handle it gently to avoid bending, cracking, or breaking it. Proper drying is also essential because it helps prevent several common defects. For example, if drying happens too quickly or unevenly, the piece can develop cracks, warping, or even air bubbles trapped inside the structure. These defects can ruin the final product or cause problems during firing.
Assalamualaikum and hi everyone. My name is Muhammad Haikal Hazim Roslan. You can call me Haikal. My matrix number is 242100143. So for the scene 4, I will explain the final stage of our project, which is firing, the final product, and also our team reflection. After the drying process, the greenware is placed into a furnace for firing. This step is very important because it determines the final quality of the ceramic. The temperature is increased slowly and carefully, following a controlled firing profile. This is to make sure the ceramic does not crack due to sudden temperature change. During the firing process, a few important things happen. First, any remaining moisture is completely removed. Second, the particles inside the ceramic start to bond together through a process called sintering. This happens at high temperature where the particles fuse together without fully melting. Because of this, the ceramic becomes more stronger, denser, and more durable. It also improves the mechanical properties such as hardness and strength. After the firing is complete, the furnace is cooled down slowly to avoid any crack or internal stress. Once it is fully cooled, we can get the final product. The ceramic now has a smoother surface and much better quality compared to before. Throughout this project, every team member contribute to different parts. Some work on a material preparation, some handle casting, others focus on firing, and some did the video editing and recording. From this project, we not only gain a technical knowledge about ceramic processing, but also improve our teamwork and communication skill. That's all from me. Thank you.